third one, 9.192.168.0.0. Yeah. Look good? Am I missing anything? Don't you all speak up at once?
Permit AA.
Well, I'm a standard access list, not an extended access list. So permit any.
But
Why?
because of the implicit deny it.
Any. Now, I gotta figure out what I want to apply this to. So, this is on R1. Which interface do I want to apply it to? The one to the ISP router or the one to the switch? And which direction? Everybody speak up at once. What do you think the logical place it should go?
Top side.
Towards the ISP? Okay, outbound or inbound?
Outbound.
Wrong. This is one of those things where I disagree with some of the stuff that's in the lecture for standard access list. If I put it there, and I could, and guess what? It will work. In this case, and IP access group, RFC 1918N. That's 5. I go too fast. Sorry. 6 we've already done. I've already re-IP'd it. I did that because I read through the entire thing. Source. Inside. IPNAT. Source. Actually, excuse me. IPNAT inside source. Static. The local IP, the global IP. So local IP here in the first case is 192.168.54. And the global IP is 201.68.109.137. That makes a static translation. A little thing that, oh yeah, we just started that. IPNAT inside source, static. Static means it's a one-for-one translation. So that will add that to the NAT table. Now, I have to define which interface is the inside interface for NAT and which interface is for NAT. I'll do that next. Pause in here so you can write that down. Slow. So, the inside interface for R1 is F01. To initiate NAT, IPNAT inside. Then guess what? I go to the outside interface, 00, and I do IPNAT, guess what? Outside. And then you guys got to do B through D. PAT, with PAT, port address translation, I need to do 3 things, one of which I've already done. I've already set that inside, outside, up. All right, so I don't have to worry about doing that again. What I have to do here is I have to define the traffic that gets translated. The traffic that gets translated. So my server network is on my 192.168.50, right? That's all going to be static. I did that in number 7. But my workstation network, all right, I've got to define that traffic as interesting by using an access list. Okay? Now, since I'm only concerned about the IP address of the source device, what type of access list do you think I should use? A standard IP access list. Then I have to use a specific IP NAT statement, okay, to translate that information that it learns from an access list to an IP address, or in this case, as it asks for in question number 8, R1's external interface, which is fast Ethernet 00. So, let's define the interesting traffic. So I will go ahead and do access list 10 permit 172.21.0.0. That's it. That's just setting up the interesting traffic for the NAT statement. I made the access list number 10. Right? Now, I have to do the IP NAT statement. IP NAT. And the source this time is going to be a list. Okay, which was access list 10. Okay, and it's going to go and get translated out interface fast Ethernet 00. Alright, now if I hit enter right here, first one to the party wins. Because it will translate the first person going out to the internet, the first device going out to the internet, to that interface's IP address. Okay? Everybody else is just, well, gotta wait for it to time out. But if I put the parameter overload, that's what sets up port address translation. So that that interface's IP address can be used by everybody from that access list. That source network from that defined in that access list. Everybody understand that? Okay, that allows it to be used as a port address translation, not a straight network address translation. It's a one-to-many versus a one-to-one. So I type in overload. That's that. I've already done the interface NAT command. So that's number 8. Number 9. Number 9 you should be able to do. You've done DHCP before. Number 10. Number 10 you've done in homework. You should be able to do that. Number 11. You should be able to do, you've done enough access control lists. The thing with the access control lists, be very carefully. Alright, as to what access list is going on what router, what interface, what direction. Okay? Now, 11 and 12 you're going to spend a lot of time on. It doesn't look like you're going to spend a lot of time on it. You're going to spend a lot of time on it. Okay? I'm a little vague. Hold on. Alright? This is going to separate the people who get A's from the people who get something else. Okay? Now, number 11 is pretty straightforward. Allow SMTP. Everybody knows what SMTP's protocol port is, right? TCP25. BlackBerry services. What in the world does BlackBerry use as ports? Research project. Better look it up. Okay, World Wide Web, secure HTTP. Yeah, that's pretty easy. TCP80, TCP400. Number 12 is where you're going to maybe lose your mind a little bit. Okay? allow hosts on the workstation network to access the Active Directory services over on server 192.168.50.4. What protocols does Active Directory services imply? I'll look that up. There's no one magic bullet for that. Okay, if you think there is, you're not gonna get that one right. This is a series of points. A series of points. Okay? Block workstation host from accessing 50.43 by SSH, that's pretty easy. Block all workstations host from being accessed via telnet. Again, know what direction that goes in. Ensure all other services are allowed into the workstation network. Okay, on number 12 there, create and apply access control lists, plural. You're not gonna get this done with one ACL, because you're talking about traffic going in, coming out. Remember, we can have how many access lists on R3? 1?
4.
Bingo. 2 inbound each interface, 2 outbound each interface. Okay? And I'll go over 13 here in a second. Do you still have a question?
Just to ask it, the NAT is gonna happen before it's compared to the access list. That when
Where is NAT happening? Where is NAT happening?
Like
On what router?
R1, and that
Okay.
one we're talking about R1. Yeah. So that's just my question: is it something's going to come in a port if there's a
You are thinking correctly. I'm gonna say that because I don't want to say anything else because people are not gonna get that right.
Okay.
All right, you guys, to his point. All right, maybe print out the lab and look at where the packet's coming in, going out, and just think and make a little table. Source address, destination address. Packet goes through here, okay, did anything change? Packet gets to here, what changes? Packet gets to here, did anything change? You gotta think about that. So we're dealing with translations, right? You write the ACL and you put the wrong IP address in, guess what? You're gonna get the question wrong. Well, you will lose some points. It won't be completely iconic, right? But you're gonna lose points. You get the syntax right, that's what we're playing. But at this point in time, you've got to be able to interpret how an access list is supposed to be set up given the parameters of your network. Make sense? If you don't think that this is important, I was at a customer just this week. They were doing inner VLAN filtering with access list from one VLAN to another. I set up a scan. I go, you guys aren't doing this right. Went into their core router where they were doing this. And guess what? They inverted their extended ACL. Source and destination flip-flop. Okay? Maybe he didn't have it written correctly. Then went into the interfaces and they're like, oh, it wasn't applied anyway. But they swore up and down. They were filtering in between VLANs. And guess what? They said that they had been doing this for 5 years. Whoops. Okay, so yeah, this gets granular, this gets detailed. There's a reason. Okay? If it's right, good. If it's wrong, well, either A, you can circumvent security, or B, hopefully it just don't work and it's broken and well, you gotta go figure out how to fix it. Okay? A lot of network engineers, a lot of people just coming into the security practice, they can't figure it out. I'll permit any. I don't want my boss on my ass. Wrong answer. Wrong answer. All right, last one, configure OSPF area authentication. I got a few minutes here. It is between R1, R2, and R3. All right. It's the same thing on each one. So the question states, configure area-wide authentication for all OSPF Area 0 using the MD5 key of Cisco. Okay? Two things you gotta do. You gotta do a command on the interface, and you gotta do a command within the OSPF process. Alright, so in R3, it doesn't matter which router you do first. Alright, go into the interface that faces Area 0, which for 2 and 3 it's fast Ethernet 0, 0, for R1 it's 0, 1. And the command to set up the OSPF key on the interface, IP OSPF authentication, message digest. Hold on, I got that one wrong. Authentication key, sorry. Authentication dash key. Alright. And then Cisco. And then router. OSPF 100. And then area 0. Authentication. This is digest. Now take a second to time out. You get it. There it goes. Oh, that's and the same thing on R2 and R3. So, and it doesn't matter which order you put them in.
You did the router command from the interface configuration?
Yep, and it goes straight into the router configuration.
It's not taking that online.
So int, I'm on R2 now, F00. IP OSPF authentication dash key. Cisco. Router OSPF 100. Yep, it's process ID.
Yeah, it didn't even, like, it doesn't even take router. Yeah,
Oh,
it's
really?
whatever.
Area 0 authentication. There's digest. And R1, make sure you get the right interface, which is 0, 1. And see, there just came up. F0/1. IP OSPF authentication dash key. Cisco. Area 0 authentication. There it goes. That loads. Okay. You should see it bounce and come back up. And creates adjacency. Two commands, one on the interface, one within the router process. This is so that we don't get rogue routers on our network. Okay, that can dump our routing tables. Questions on that? Questions on anything? You guys should be able to finish up lab 2 now. Alright? You can send it to me if you get it done this weekend. I'm not gonna start grading it till next weekend. Why? Because out of 80